Autonomous Systems Engineering at Fraser Nash Consultancy. So, and it looks like we have a poll that is coming up, which I'm going to invite the audience to ask. Apologies, Eric, you did ask me to promote this, but it's up on the screen now for people to address. So Chris, if you wouldn't mind taking us through your presentation, and then we can move on to the final presentation or panel session of the day.
Great. Can everybody see my screen?
Yeah, we can see and we can hear you, Chris.
Great, perfect. The technology works.
Yay.
Perfect. Thank you very much. So I guess one of the perils, or potentially one of the advantages of being the final speaker of the day, is people have covered a lot of the themes that I'm going to talk about. I guess my perspective is going to be slightly different. I'm going to be looking at how autonomy can start to offer solutions to some of our challenges. And of course, I think there'll be a bit of a reality check at the end of my presentation about what's possible now. It's very much future facing. But as we've heard from a number of the speakers, improved efficiency across the whole of aviation is really a commercial and sustainability imperative. We know what we've got today in terms of infrastructure is congested and maybe not fit for purpose for some of the emerging concepts that are coming out around urban air mobility, for example. And as I say, I think autonomy can be a great enabler for increasing that efficiency, but it's absolutely critical that we at least maintain safety, if not enhance it. And as I say, we'll cover some of the challenges around autonomy as well. So where are we today? The image on the left is quite a good visualization, really, of where we are today around airspace management. And that's the view of some of the main air corridors into the key London airports. So what we've seen there is we've created a number of air corridors and we've got holding stacks, and this serves to constrain the environment. And that's really important. And also on top of this constrained environment, we've got some clearly defined rules which are there to maintain safety. So we're looking at things like minimum aircraft separation. And then another level on top of that is all the flight plans are filed in advance. So the air navigation service providers have some kind of view of what's coming into the future, which brings a bit of predictability. And obviously these plans are executed by highly skilled pilots. So that also helps. Things don't always go exactly to plan, obviously, but it's quite a good starting point. And in summary, really what that does is it turns a very complex environment and situation into something a little bit more constrained, to the point that humans, i.e. the air traffic controllers, can manage and coordinate the situations with the help of some automation and decision support. So these days, the air traffic controllers have got tools that predict aircraft position forward into the future. That's not to say that the air traffic controllers don't have a really, really difficult job. There is so much complexity out there. At busy times, we are asking them to do probably too much, in all honesty. So the end result of all the need for these constraints really is a limitation on capacity, due to the rigidity of the airspace design and the rules. Now, there are programs ongoing to look to redefine some of the airspace in the rules through things like the CESAR program. But ultimately, I think we're going to hit a limitation on what humans and automation can achieve.
Chris, can I just interrupt? You're actually sharing your slide and note screen. So if you have a second monitor, you might need to unplug it and reshare.
Oh, what's going on there then?
Yeah, we're seeing all your notes, including your shopping list. There you go.
Okay, the technology didn't quite work then, so good job we're not trying to do anything difficult like autonomy, isn't it?
Heaven forbid.
So yeah, as we've also built a lot of safety margins into this situation, and that's really necessary because of the way the system's operating. So at the moment, we're expecting an air traffic controller to pick up that there's a potential problem going on, determine a course of action, deliver commands up to the pilot via voice, and then the pilot has to act on that. And that may only be a few seconds, but ultimately these aircraft are flying at a serious speed. So that separation distance needs to be quite significant, and that again limits capacity. So looking forward into urban air mobility, what we're really looking at from user demand and from the commercial realities of the business models is something that's much more point to point, and that's going to lead to a much denser network of access points. rather than kind of the hub and spoke model that we tend to have, we need something that's much more flexible. And the challenge this brings is there's so many point-to-point flight paths that platforms are going to want to take. And you add another level of complexity by putting this in an urban environment where we've got buildings. You know, airports tend to be a little bit out of the way, huge open spaces around them. We're now moving into a place where there are many, many more obstacles. So you also then factor in the user convenience demand. The customers are going to expect this to operate kind of like the ride hailing services like Uber. And that reduces predictability of operations. And it also means there's going to be a lot more surges in demand based on events around the city, whether that's, you know, planned events like concerts or, I don't know, some kind of accident occurs at a choke point on another transportation system and more people want to take advantage of the services that are available. So again, that's a further challenge on top. Now, the breadth of presenters and attendees at today's conference kind of shows that there's going to be a lot of variability in the types of vehicle that are going to be out there. We know we're going to have multiple services sharing the airspace. Air taxis are very different from delivery drones, for example. They have very different capabilities. And again, that just increases the difficulty factor because you can't have one size fits all rules very easily. They don't scale very well. If you did take that approach, you're looking at significant safety margins, which is kind of what we've got today, and it doesn't help the scalability. So what we've got is a significantly more complex environment, essentially. And given we're already kind of at the edge of what humans and the automation can currently achieve, I think we're going to push it beyond that once we start scaling urban air mobility. So some of the main advantages of autonomy really are around the ability to deal with situations that haven't explicitly been designed for, to cope with the unexpected, to make very fast decisions in very complicated problem spaces. And I think there's a real opportunity here with urban air mobility, not starting with a blank sheet of paper, but there's a bit more flex there, I feel. If urban air mobility can prove some of these autonomous technologies, I think we can deploy them back into traditional airspace management. And that could be a benefit for wider aviation as well. So there's a number of ways you can look at autonomy and how it can be used in urban air mobility. And in my mind, there tends to be a bit of a spectrum between distributed approaches. So I think this was mentioned earlier as the Jetsons approach, a bit of a free-for-all, all the way over to quite a centralized solution, which is more akin to what we have today with heavy air traffic management. So if we start off at the distributed end of the situation, effectively each vehicle in the system or system of systems is focused very clearly on their own goals. That can be a bit problematic because you can encourage competition between vehicles and vehicle manufacturers. So about how they kind of operate and the rules they follow. So if you imagine in today's world, driving a car, you sometimes see drivers trying to push into a traffic jam or a queue at a junction, and they're relying on the fact that other drivers will hit the brakes and prevent a collision. That's kind of taking advantage of a situation. You could imagine we end up in this space in a very distributed approach. There's also another issue here in that emergent behavior is a real problem in even traditional complex systems of systems, let alone when we start bringing autonomy into the mix and very complex behavior. And fundamentally, we don't really know how to verify and validate for this. So emergent behavior can be quite beneficial. You think about flocks of birds in nature, and what you're seeing there is something that looks really, really intelligent, but it's based on only 3 or 4 very simple rules. The flip side is when we get undesirable emergent behavior, you end up in situations like we sometimes see on the stock market, where independent algorithmic traders all of a sudden create a crash out of a small decline in share price. It can be quite unpredictable. And there's a term that's sometimes used around emergent behavior where we sit at the edge of chaos. And to me, just the name of that doesn't sound like somewhere we really want to be in the aviation industry. There's too much at stake. So if we move more into the centralized approach at the other end of the spectrum, like I say, this is quite close to what we have today with air traffic management. Now, it can be a very coordinated system, which is really, really positive in terms of achieving collective goals. So whether that be minimizing overall journey times, maximizing energy efficiency. But it does bring scalability challenges. To control in such a centralized way, you need really reliable communications infrastructure, which isn't always possible in an urban environment. And it also means the system as a whole is slower to respond to local situations. So if a vehicle sees something it wasn't expecting and has to go back to a centralized control center to work out what to do, there's going to be ripple effects. And in a heavily scaled system, that's going to be a real challenge. So unsurprisingly, one of the answers to this kind of scenario is something in the middle. And in my team, in the systems that we develop and are working on at the moment, we tend to think of things in a couple of different tiers. So we tend to think about strategic autonomy. And in this case, this is embedded within a command and control structure of some sort. And this performs kind of the high level optimization and planning of what's going on at the macro level. So again, this can do the optimization, the planning, the scheduling, can adjust priorities. So maybe there's an emergency situation and we need to prioritize certain vehicles. That's possible at the strategic level. We then have the tactical level autonomy, which in this case is on board some of the air taxis or the other vehicles in an urban air mobility environment. And that allows the vehicles to really react to the unexpected situations at the source. And some of those situations aren't going to be known about by the centralized strategic level. What we need here is the command and control system, the strategic autonomy, to be tasking the vehicle with both a plan, but a level of authority to deviate that plan to deal with the situations that it sees that it wasn't expecting. And that's how we combine the best aspects. We don't have dumb vehicles, we have a level of capability there, but we have an overarching controller. And this is an approach that we've adopted and demonstrated in a military last mile delivery context. And that was using a mix of unmanned ground vehicles and unmanned air vehicles. And as you can imagine, the environment in the ground domain is very, very complex. We were working off-road and on-road, rural, urban environments. And throw into that the complexity of the scenario around the need for pre-planned resupplies, dynamic demands coming in driven by the military environment and operations. That's quite a complicated environment and set of problems to solve, which feels quite analogous to the urban air mobility challenge once we scale. So if we take this into an urban air mobility use case, what we can kind of see here is two vehicles and they're sitting within kind of like bubbles. So we've got a bubble around them and a short distance ahead. And you can imagine that this is almost like a small dynamic air corridor. I think it was mentioned in one of the previous panels around it's a 4D problem to solve. So the air corridors move in time as well as space. And what that means is the overarching strategic autonomy in the command and control centers can manage the airspace much more efficiently and much more dynamically. So in an ideal scenario, you create these bubbles around the vehicles and they're never breached. But of course, we don't really live in an ideal world, and we see on the news all the time incidents where you have, say, a delivery drone just appear in the flight path that you weren't expecting to be there. The command and control system knows nothing about it, but the vehicle's onboard sensor suite manages to detect the vehicle. Because you've given the vehicle some level of authority to deviate from its plan within its own bubble, the vehicle can now make a rapid decision to change course and avoid the problem. But this is with kind of minimal delay. It's quick reaction, minimal delay, safety is preserved, and the efficiency of the wider system is largely maintained. And then, of course, you can feed back that information into the command and control system, and that can maybe plan paths around that area until it's known that the offending vehicle has disappeared. So hopefully I've given a little bit of a taste of some of the potential for autonomy and how it can help solve some of the challenges. But of course, we live in a bit of the real world. So there's a quote that's come from the automotive industry that I think sums this up really quite well. And that's, when you're 90% done, you have 90% to go. And that really demonstrates the difficulty of moving from a technology concept through to a realized capability and service offering. So in the world of autonomy, what do we think the remaining 90% of effort is? Well, lots of concepts work really well in a simulated environment or in a sandbox, basically a heavily constrained environment. But how do you move it into the real world where life isn't so straightforward? Well, assurance and certification are kind of some of the vehicles we use to demonstrate that we can operate in the real world. And this is where the crux of the challenge really comes up. So there are fundamental questions that aren't yet answered in this field, or even have a consensus. So how good is good enough? Do we want to be better than a human? Do we use our traditional levels of, say, software or system safety and reliability? What's the right answer? We don't really have much standardization or good practice to lean on in this area. It's a field that's evolved very, very quickly. We certainly see that existing processes do not always transfer well into this area. So for example, classical requirements approaches don't really work very well when you're using machine learning based approaches, and the requirements are effectively training data. Deep learning approaches around perception are very, very popular. Automotive are investing heavily in this area. That's great, but they're a very complex black box, and you can't really verify and validate and demonstrate safety. So we're in this situation where technology is developing very, very quickly. The verification, validation, and assurance methods are having to play catch up. Now, the good news is the field in that area is growing really quickly. There's some great research going on, but it is still playing catch up. And then take it one step further, and it's kind of by necessity, the standards and the certification methods around autonomy are waiting for the outcome of some of the research around what is sufficient V&V. How do we assure this stuff? And ultimately, the standards and the certification are the gatekeeper that determines whether your technology sees the light of day. So you have to exist in the real world with this stuff. In the future, we're going to have lots of capability, but right now, I think you've got to make your technology choices based on what your product development timeline is. And I think we all need to support the research community in answering some of these hard questions, because ultimately, if we don't find a way forward of how to assure autonomy, we're not going to be able to leverage the technology, and that's going to affect the future potential of the aviation sector. So I'm really happy actually that collaboration has been mentioned in some of the previous talks. I think that's something that is absolutely necessary for us to realize the potential that we've all talked about today. So that's me. Thank you very much.
That's brilliant. Thank you very much, Chris. I'm probably going to have to borrow that 90% quote. I think that's closer to the mark than I've seen a lot of statements. I used to say that 90% of the cost of a design is determined in the first 10% of the timeline of a project. But I can see where that fits quite well with that. Right, so I think this is actually going to lead us right nicely into our final panel discussion of the day, and I humbly apologize to everybody in that my timekeeping for the afternoon has slipped away from me, in that we're about 23 minutes overdue, but I'm hoping that everybody agrees that it's certainly been a really interesting day so far. And looking at the feedback from the panel, it certainly looks like many of you agree that a lot of, there's a couple of people who are not as impressed, and for those, I would really welcome their feedback to try and make this forum even better for the next time. So let's get into this discussion on autonomy, and is it going to be a reality, and when is it going to happen? And I'm very excited about autonomy, and I'm also very afraid of it. I see lots of different presentations and different approaches to autonomy. So maybe we'll start with Martin, because I've seen some of your presentations on the subject. When do we think it's going to happen? And do you think that there's enough happening within the industry that you're all talking the same language? Now, of course, I'm not an autonomy expert whatsoever. I just don't want us to end up with a VHS versus Betamax kind of decision. And for people old enough to understand that, you'll be laughing. For you younger people out there, well, history lesson. So Martin, do you want to kick us off, please?
Yeah, sure. Well, I'm certainly old enough to remember Betamax. I think, well, first of all, thanks for this forum. And I think there's lots and lots of communication still to be had. And autonomy, if you look at, say, the automotive sector, you know, what we've been at it in earnest probably 7, 8 years, and still a lot of work. There's still a lot of big data problems around safety that are still going through. And even though in the air, whether it be urban mobility or broader, there's less obstacles. A lot of the technology in terms of being able to fly autonomically and certainly autonomously is already there. There's still an enormous amount to be considered around the standards and around bringing people together. And that's at multiple levels, not just safety, but just in the proprietary and the open standards and the technologies that we want to use. So when I listen to this, I think of, and I loved it, the present. In fact, I sat for the prior one with Samir, and then obviously I heard Chris's. It begs a number of questions. And from my perspective, we're an R&D company. I have two companies, one that actually focuses on parcel drones and one that focuses on the eVTOL aircraft. And one of the challenges, and there is some overlap, is when we think about air traffic management or air traffic control, and we obviously have thought about centralized and decentralized approaches. And one of the things that we come back to, because I'm ultimately focused around the greater area of the city, is that how do you think about grid flow, whether you're dealing with asymmetrical products or you're dealing with symmetrical alignment of products at certain flight separations. And one of the things that we've come up with is that parcel drones will need their own flight envelope and their own level to fly at, completely different to what eVTOL aircraft fly at. And one of the main reasons is that we coined a phrase a long time ago, and it kind of stuck in the US. We called it random autonomous routes. And that's, if you think about the sheer volume of parcels, and we're talking about, if you quote Jeff over at Amazon, 85% of their products, they would love to put in a 7-pound payload and float it above the skies and deliver it to your garden or your front of your porch or whatever. That means that they're looking to put, in the next 10 years, several million deliveries every 6 months. That's an enormous amount of capacity. And the problem is, if you were to assume that that was there today, and you were to stare down at the kind of sub 500 feet sea level, what you'd have is a spaghetti junction. You'd have all these different routes, and no day would be the same because people's ordering habits change. And so you need to be able to find a centralized approach where they can build their own predictability completely autonomously, so that they can fly with a floor and a ceiling, where they're only dealing with that level of proprietary technology, and they've got the ability to create these random autonomous routes. So by taking that approach, it does away with the idea that you're flying by line of sight with helicopters, or you're dealing with point-to-point destinations of eVTOL aircraft by simply cutting the airspace. I think it would be very difficult to create, let's say, I don't know, we did a test in Paris and in the UK, but let's use London. Let's say you can imagine that there's 7 to 8 point-to-point key destinations for urban air mobility. And you're going to fly them, let's say, at 600 feet. And if you've got large skyscrapers, there are going to be some exceptions to that rule. You are not going to want to see a parcel drone anywhere near that airspace, and not at that significant volume. So it's most likely the only solution that we've come up with, that we've started to discuss, is cutting that airspace between these two different technologies, between traditional transport and logistics. I think, though, autonomy, if it's going to be successful, whether it be just for urban air mobility and for broader aviation, is it almost needs to be thought about like a zero-sum game. If you think about when jets got bigger and bigger, and they started to figure about flight redundancy, whether it be 3 hydraulic systems or 2 flight management systems, 2 autopilots, we put a jet in the air with a view that it's a zero-sum game, that the safety is the number one thing, and there is all this redundancy. Where autonomy will probably have to be at least that, even for these taxis, as we want to call it, or I call it air shuttles. I think the first eVTOL successes will be just point to point, and they'll fly on a track. And to be frank, even though they're going to most likely have some ability or flexibility that Chris alluded to for pilots to take exceptional actions, for the most part, they're flying already autonomously, and with very little movement to change their flight path. I think that all of the redundancy consideration that has come before us will happen again if autonomy is to be really successful. But I think autonomy as it relates to urban air mobility versus parcel drones will be fundamentally different. There's enormous amounts of, I wouldn't call it machine learning, but autonomous instructions and automation in the way that the flight map is created for these different deliveries, because it's changing so fast and so rapidly day by day. No one route will ever be the same at any one point. Yeah, I mean, that would be my initial view.
Right. I'm really jealous of your backdrop there. I'm thinking about relocating outside myself. Alex, you've been patiently waiting all day for your turn, and we had a brief chat the other day on autonomy and your role within the CAA. How are you seeing all of this coming together, and is it coming together in a way that you think that the regulator would like it to come together?
So absolutely, and Martin and both Chris beforehand made a very important point right there. Is about how we use autonomy in this industry. But if we can take a step back here and start seeing what are the challenges involved with something like this, starting by the fact that there is no clear-cut definition by what do we mean by autonomous systems. Whoever you ask, you're probably going to get a different answer as to what they consider something being autonomous, or if it's just automated in the end. You've got different levels of automation from different entities, different standards organizations, and so on. And I think that's one of the big challenges that we need to try and address first, and see what do we mean when we talk about autonomous systems, and what kind of levels are involved in such systems, whether it's automated, whether it's autonomous, or anything between those two. This on one hand is obviously very positive because it shows the different points of use and the different ways that people are approaching this challenge as well. Because when we talk about innovative technologies, especially in the aerospace and aviation industries, there are a lot of companies who do not come from what we consider as a traditional aerospace background. So they have different views, different opinions, different definitions on certain topics, especially when it comes to these kinds of technologies as well. On the other hand, it's important for everyone to come together and start addressing those challenges as one. Both the industry, the regulators, the policymakers, and all relevant stakeholders and experts, because I truly believe that this needs to be a collective and collaborative effort in defining what do we mean when we talk about these systems. Where do we see these systems being applied in the future, in what way? Chris mentioned the distributed versus centralized approach as well, but it's also which domains within the industry. We've talked about future air mobility and eVTOL aircraft, pilotless aircraft of the future, as well as UTM and ATM applications. Obviously, these kinds of domains have different safety concerns, different risks involved when we're developing autonomous systems and automated systems as well. And I also want to point out the fact that just because we see autonomy as the whole grail of the future, automated systems on their own have different kinds of challenges, and we need to realize that and address that as a first step, if nothing else, before moving on to more advanced topics such as fully autonomous systems in this case. On the other hand, we need to also take a different approach now. Given that this is such an innovative topic, it's something that is going to come our way, whether we like it or not. And we need to be able to address it when it reaches the CAA, essentially to be regulated, because if it comes to the CAA and we then need to regulate it, it means we're too late to the game. We need to involve the industry. We need to talk to the industry and collaborate with the industry to see what is actually out there, what is being developed, what is the views of the industry and the experts and other policymakers and other regulators worldwide as well, and what do we need to do about it? Because if we don't understand what is being developed, then we can't regulate it effectively to that end. And it becomes very apparent, and I'm very happy that I'm seeing this collaborative spirit, let's say, within the industry and within the innovation of the aerospace industry, whether it's UAM, whether it's drones, pulse deliveries, or autonomous systems, and this willingness to come together and address these issues. I don't know if some of you were attending the presentation by my colleague, by Frederick, this morning, where he touched on the topics that we're addressing as Innovation Hub. The point of setting up the Innovation Hub in the first place is to be more proactive to these new technologies and these novel types of operations as well, whether it's beyond digital line of sight drone operations or future mobility, or in this case, autonomous systems. And a key factor in being proactive and actually coming up with effective regulations for the future is involving the industry as much as we can, as much as possible, so that we get a better understanding of what's going on and how can we support the industry in their efforts. And when those technologies become a reality, the regulations can evolve with them and not restrict them as such.
Sorry, I'm catching up with my unmute. Thank you very much for that. I'd like to get Gary's opinion on the autonomy question and your role within future flight, and whether or not you're seeing consortia start to form that are exploring the autonomy question, and really try and understand how government organizations can fund investment to help bring autonomy to fruition.
Thank you. Darryl, I'll cover a couple of those issues and a little extra one if I can. So firstly, for us in the Future Flight Challenge, we've always seen autonomy being somewhat front and center. I find that when I talk about this quite widely about the future of aviation, we instantly talk about electric or other kind of low carbon things. Everyone understands that completely. But we keep emphasizing that the vision we have of a much more distributed aviation system, autonomy is a key enabler. So for us, it is front and center, but it isn't for everyone. So we certainly have people talking to us about that. There are undoubtedly consortia forming or in the space of autonomy. I think there's a little more to come there. I must admit, my take is that some of the players who are more vehicle focused have yet to understand that autonomy may eventually be the enabler that lets their vehicle fly in volume. So I think it's coming, and absolutely we expect to fund activity in the realms of autonomy in future flight. And I know a few people have some angst that future flight is not intending to fund vehicles. It was never intended to be a vehicle program, but we've always said it can fund some technologies which are vehicle technologies that allow the vehicles to enter this new aviation system. Autonomy is absolutely one of those. So anyone who thinks we don't fund vehicles, autonomy is something we could fund. I'd like to make another point, if I can, just while I've got the mic. I think this is something that we're debating quite heavily in future flight. Autonomy is not just an engineering science. Autonomy is a huge social science experiment as well. And we've had quite a lot of conversation. I work for UK Research and Innovation. As many people probably know, that's also the home of all the university research bodies in the UK, including ESRC, which is fundamentally the social sciences research body. We probably have as much early stage engagement with the social science research body as we do with the engineering research bodies for this kind of area. So for future flight, we've got the general public acceptance of new forms of flight, which is that's fine, it's not this panel, but the public's acceptance of autonomy, its understanding of autonomy, what do we mean by it, what are their concerns, and that's everything from this deep emotional, psychological loss of control. So not often when people step on a plane, they have their first panic because they're not in control of it, but they're somewhat satisfied with another human being who's also invested in the safety of the system. That human reaction to loss of control, right through to how do these systems interfere with each other, what degree of intrusion do they bring, what's the inherent safety of them. I think there's a whole load of issues. So I will just stress that as well. Eventually, autonomy, the technical issues of autonomy are solvable. They are not trivial. I've worked complex systems. We've got 2 autonomy experts online here, if not 3. It is complex, it is not trivial, but it will absolutely be solved. The final hurdle will be whether the public will allow us to use those autonomous systems and they believe in them as we do. So I think that's a really big theme for future flight as well, Darryl.
Chris, I see you nodding your head to that. Do you want to add to this discussion on I guess the social experiment? That certainly seems to be an interesting strand to pull.
Yeah, I mean, the technologist in me would love us to just be able to go big bang, autonomy, take the human out of the loop and have a happy ending. But as Gary says, that's just not realistic on many levels. The societal acceptance point is really, really critical. The media narrative around some of this technology is a little bit unhelpful. Part of that is because it's quite difficult to understand what's inside the box. As somebody who works with this technology every day, I struggle to understand what's inside the box. So how can we expect the general public to accept such a thing? And the definition point that Alex brought up around what's autonomy, what's AI, again, the discourse at large in society is not particularly helpful, and everything just gets bundled together. And these fields that kind of co-evolve have come on such a long way in such a short space of time. Everything has got to catch up, whether it's assurance, it's people's acceptance, it's media understanding, and ultimately, you only have to look at what happens when there's a self-driving car incident. Mm-hmm. It makes the news. Of course, it makes the news. People get worried about it, and it's our duty as engineers and professionals in this industry to, first of all, try and stop the accidents happening as much as we can. We don't have a license to kill people in the quest for sustainability, but also get the conversation moving in the right direction and open it up widely to a broad set of stakeholders.
Yeah, absolutely. We've had a question come in. It was directed at Gary, but I'll open it up to everybody because I think you all have a different opinion on it. So what do you think we can do to help shape public perception, especially with reference to autonomy? Gary?
The famous unmute problem of Zoom calls. Directed at me, maybe I'll take the first shot and say just a few words on that. I think we're developing a strategy on that. There's much more to come. But the most important thing is what we should not do, which is solve the technical problem and then engage at the end and tell people, here's a wonderful technical solution. You just need to accept this because we're very clever scientists and engineers, so we have to engage throughout. For me, a couple of thoughts spring to mind. One is, and we've not done this yet, but we all have a responsibility to explain to the public the degree of autonomy and automatic systems there already are. I think it's not widely understood. People are very reliant on some degree of this today, but it's not in their face. So there is a kind of a media-friendly storytelling to explain what's happened already and what's already widely out there, which will surprise many people. I think an awful lot of people would be amazed the degree of autonomy that comes on a current flying aircraft, the amount the pilot does interact and doesn't. So the stories to tell there. The second thing, and this is something Future Flight's very keen on, is looking for these early socially acceptable wins. So where you can use these new technologies for something that is obviously of social value. So the trade is quite early made, that you're prepared not to give up, because I think Chris's point is really important. We have no license to kill people in pursuit of sustainability, but what we can do is bias some of our early demonstrations, things that themselves are obviously socially acceptable, and then tell the story that the thing that allowed that good story to come to pass was this autonomy. So we do need to create that narrative as well. It's engagement throughout is important.
I think there's a nice link with the CAA and Alex. The CAA published a social license paper a few weeks ago, which I read and found very interesting. And I think it hit it right to the point. And I've shared that with some people I'm working with in the US, CAMI, the Community Air Mobility Initiative, and they took it straight to heart. What are your thoughts in terms of that social license and what we need to do to help shape public perception?
Absolutely, and I think Gary covered that topic perfectly right there, because when we consider these novel technologies and novel operations we're seeing currently arising in the aerospace industry, in the aviation industry, nothing can be developed in isolation, because aviation as an industry is a system of systems, if we can call it that, essentially. Therefore, you cannot really develop something in isolation, expect it to fit it in and integrate it straight away with no issue whatsoever. And this is particularly applicable to the public perception of such technologies as well. If you develop something and you expect people to accept it from one day to the other without being aware that this is coming their way and this might be the future as well, you might hit a barrier there. So it's very important, as these technologies are being developed, developed and matured to engage with the public as much as possible. We've seen operations shut down in the past because of this lack of public acceptance in various places around the world. So it comes to show how important public opinion is when it comes to these new types of operations and technologies. There was a recent article that made the news, I think, yesterday about the topic of driverless cars and autonomous driving their vehicles, where 3 out of 4 Americans wouldn't trust a driverless car. They wouldn't want to get in a driverless car. And this comes to show how important this is. If we're talking about something that it's been developed for so many years now, and 75% of the public still doesn't feel comfortable with it, then why we're developing something that might never be in use, and what's the point down the line, which makes the point of involving the public as much as possible so important when we consider something so innovative and so disruptive in our industries as well, because the public can make or break any kind of innovation regardless of the industry, regardless of where you apply it in the end. And I guess it's in human nature, if you take it more philosophically, to be more skeptical, if not straight out scared of things you don't understand and you have not been, I want to say, educated in a way about these new innovations and these new types of technologies as well.
Yeah, I agree. Martin.
Yeah, the thing that I come back to is that most great innovations or cycles of innovations happen over a 15-year cycle. And I wonder whether we can achieve most of autonomy by still having piloted vehicles. So the fact that we give the public the assurance that there is a pilot, let's take, for instance, air urban mobility. I think the last time at your conference, I think I mentioned that it really doesn't get economic, even on point-to-point routes, unless you're carrying 6 to 8 people. There's just not going to be the economies of scale there. But let's say a lot of these aircraft, we've got a 4 or 5 seater. Let's say that goes up. One of them stayed for the pilot. For the most part, all of the autonomy and all of the safety that we can get by letting the machine do the work versus giving the control to the pilot can still give and provide the assurances to the everygoing public that there's someone there as a backup. Most people don't know that when pilots are in the air, what even fly-by-wire is, and the fact that the pilots are doing very little when they're in the air. They change in their DAT when there's turbulence and stuff like that. They do for certain landings, but for the most part, there's an awful lot of autonomy that's still in the system. So maybe we will arrive at a point, certainly within this 15-year cycle, where we may not, or we may have to face that we may not get complete assurance from the public that they'll feel comfortable ever being in, an air taxi or an air shuttle where it's not piloted, but we can still achieve a lot of the benefits of autonomy. And I think that wouldn't necessarily be a bad place to go. The idea that I think most people think of full autonomy as being where you step onto an aircraft and it takes you from point to point, and there's nothing than the windows and the seat that you're on and some voice overlay, and that's it, and everything else is being done by a computer. Wouldn't that be great? But I think it's more practical, more likely that we'll achieve a lot of those benefits and still have a pilot. And certainly I think the CAA, the FAA we've been talking to are pushing for that. I think the other side of it is to say, in terms of public acceptance, I think the problem with science and all the things that I've done over the years, I've noticed that unless you're grounded in really solid science, you really don't want to come out too soon, even with simulations, early education, what's happening, because the public cannot understand that and they can't contribute to it. So I think that point in terms of the education drive comes back to what is the outcome? Is this 15-year cycle to operate and provide the assurances of safety, but still provide a pilot? And then there isn't a lot of need to go into, saying how safe these aircraft are at a level where we're directing the conversation around autonomy. Or is it indeed that the goal is ultimately to remove the pilot and let us go full autonomous? And therefore, once we've locked down the science, we're talking about how reliable it is. We're providing those simulations. We're showing what that experience is like. And the end consumer view is very different to the road that all of us and others in the industry are going to travel. And I haven't really visualized what that looks like. I understand what product marketing, how we might share that story. but I'm not sold that we even need to be at full autonomy in order to capture the benefits.
Interesting. Just building on that, something that I've always been waiting for the killer question to come, because autonomy isn't just in aviation. Autonomy is across all forms of transportation. And right now where we're at with eVTOL and the range based on energy density of batteries gives us that. So I've been waiting for somebody to say, well, what happens when we get autonomy on the ground in either vehicles or in the transport system, and how is that going to affect this whole business model of electric aviation? And I used to think about that a lot, and the conclusion that I came to was that autonomy on the ground transportation modes is just going to increase our predictability of our journey, so that we will know that they are going to be X number of minutes from here to here using ground modes of transport. So what that does to the business model for electric aviation is that it just pushes the range requirements out a little bit more. But of course, that comes back to this issue that because the vehicles are relatively small, we need to get the pilots out so that we can get another fare paying passenger in. So Chris, crystal ball gazing, how long do you think it's going to be before we get to that point?
Well, I think that along those lines, the real challenge that we've got now with the COVID situation is there's a lot of people realizing that the commute actually was a bit of a waste of time. And, you know, a few technology issues aside, it works pretty well. So instead of having a predictable commute, do you want any commute for part of your time? So maybe the imperative in some senses eases off a little bit. I guess my thought about why we would need full autonomy over having a pilot in there is we're going to be asking a lot of a pilot to have very little involvement with the system and then step in when things go wrong. I think, you know, coming back to Gary's point about the sociological research, there's plenty of research that says that humans just can't pick up the awareness of a new situation very quickly. So using a pilot as the backup plan might not actually be a viable option. But going into crystal ball gazing, I would be thinking we'll be wanting an impact from autonomy and some adoption in the transportation system in the next 20-25 years. I don't really see it being the killer technology too much sooner than that because of the scale of the assurance challenge at the minute. You know, we've seen the self-driving car situation being quite challenging. The environment's more challenging than we're talking about in aviation, but there's still a lot of work to do. And I think if we're going to get it into aviation, I think we've got to piggyback on all the work that's going on in the ground sector. There's a lot of money being spent. There's a lot of research being done. Let's piggyback on that. Let's not pay for it twice.
Fair enough. Gary, your thoughts, sir?
I've not much to add, in all honesty. I think Chris's last point is really important. We've just opened up a conversation with the kind of cab sector, and I think the fundamental autonomy problems, you know, the redundancy of detection, the ability to interact with people and things like that are fundamentally similar. So on that, I think it's really important we don't try and invent an aviation-specific solution when the world doesn't need us to, and the world cannot afford that. So really just wholeheartedly agree with that principle.
Right. Okay. We've got a question here from Yaswatha. How much does ground infrastructure need to be improved for creating an affordable autonomous platform? Should we discuss the need and success of an autonomous aircraft versus an aircraft operating in an autonomous transportation ecosystem? So I think one looking at the ground infrastructure side of it, maybe a bit of what I was talking before, but how much do they have to happen hand in hand, or do you think that they can happen independently of each other? I'll open the floor to anybody who wants to wade in. Or are we lost on the question?
Why not take a stab? When we talk about ground infrastructure, are we talking about technologies, or are we talking about all infrastructure to support an autonomous flight system?
I think we should open it up to all of them, as opposed to looking at anything specific on the, say, the airport side of the equation, because I think those challenges that we have in processing passengers are relatively easy to solve, and things that the industry is actually trying to move towards right now, especially with airports and social distancing, and how do you get passengers through a system in a contactless way. So I see that change happening. So I'm just interpreting the question that it might actually be more about the entire ground infrastructure systems and processes, and the supporting systems and processes.
Mm-hmm. I think the interesting point about autonomy is I don't think that autonomy will operate in isolation. I think that, take for instance urban air mobility. If you've got a passenger network with several routes in the beginning, extending to say 7 or 10 routes over the next 10, 15 years in a city, there's going to be a centralized system, because it'll be a bolt-on to the existing air traffic control system that we have today. I don't know. I don't have a view of. I know that will be semi-regulated. It won't be down to it won't be a private affair. There's a lot of conversation around what kind of control that a centralized facility needs to have over the network. I have no view on what that cost will be, but I don't think that in and of itself, if we get the science down and we get to a point where point-to-point travel, for instance, can exist, we can get the redundancy right in eVTOL aircraft. We understand what the landing distances are. We can understand what the infrastructure requirements are in terms of whether they're roof stops, arm stops, greenfield sites. Once we understand all of that stuff, I actually don't think that that's a problem that will be difficult to solve. But I don't know what the cost of investment will be.
Right. Okay. I've got a couple more questions, and I think Gary might be the right person. What international forums exist for nations to share strategies? We know that, and perhaps Alex can weigh in on this as well. We know that regulators are talking to each other. It's just whether or not there's any existing forums that you're aware of, and where will we look to get information on them?
So I'll give it a short answer. I will happily hand over to Alex. In short, certainly the regulation piece of it, the aviation aerospace regulation, that's well established, and therefore there are channels when it goes into the regulation environment that could happen. The second part, I'm just learning about, and I'm not so clear, but there clearly are a set of standards institutes as well, which is not the regulation, but it's underpinning standards. And we've only just started to engage on that and think what the standards are, and there are bodies there. My really honest answer is, from my 1 year in this role, international forums are somewhat ad hoc and reliant on kind of bumping into each other and well-intentioned conversations. We certainly as a team have had probably 3, 4, 5 interesting conversations with similar teams from other nations, where we're trying to do the right thing. In all honesty, it's a potentially challenging conversation, because you're aware that at one level we are fiercely competing at nation level with each other. At the other, we're trying to do that to develop technology, what is a global industry, and therefore a set of standards will eventually prevail. So there are conversations going on where we're trying to protect our own corners to some degree, but make sure we just don't waste you're back to your Betamax VHS, that we don't do something stupid like that. But the honest answer for me is those conversations away from the regulation and possibly the standards piece are a little ad hoc, and there's not an obvious forum that does that right now.
Yeah, I'll just interject, and then I'll ask Alex to step in. I work a lot with the Vertical Flight Society out of the U.S., NASA, and the CAMI organizations over there, and I can definitely say there seems to be a lot more galvanization in that market around standards, and the standards organizations there are very strong. And in fact, you could probably list the entire alphabet in the number of organizations that are wading in on that space. And maybe that's something that the industry here in the UK and the rest of Europe needs to sit up and take notice. And I know that there is some work on the ISO side of the regulations, but definitely more work to do. And then, of course, on June the 3rd, I'm organizing another event where we're trying to gather together Gary has agreed to talk. We've got Agility Prime, we've got NASA, and then we've got J.R. Hammond from the Canadian side of the equation, so my brethren back home. And the purpose of that is really to talk about what governments are doing in terms of supporting electric aviation. I think that just feeds off your comment that, yes, at a nation level, we are fiercely competing. But equally, we all have something to benefit from this. So, Alex, I'll just hand it over to you and ask you to comment on the relationship that you might have with the FAA or EASA, or how you think that it could be improved.
Yeah, so there's a number of initiatives currently worldwide that are looking into the topics of autonomous systems, whether they specify that it's autonomous system or whether it's automation, and whether it's being addressed as a whole or whether it's specific domains of the industry, such as ATM, as I've previously mentioned. There's a lot of interest in artificial intelligence within aviation as well, and sometimes that might overlap with what we consider and what we talk when we talk about autonomous systems as such. The CAA is currently, as we speak, starting an initiative and what we call a work stream in addressing these kinds of challenges and starting to formalize our approach to autonomous systems as well. Part of these approaches is beginning with defining what we want to do, what we want to gain out of this as well, and how do we engage with the industry as much as possible. Also engagement beyond industry with other regulators, both internationally, but also national policymakers, other government agencies as well, to see what are their views and gather expertise from various stakeholders in this topic and area as well. And there's also the interesting bit, because you've mentioned standards there, and it's a bit tricky that when we approach standards, because you've mentioned you've got so many organizations, we come up with competing standards in the end of the day, which goes back to my previous point about how important collaboration is when we have this opportunity to start something from scratch, essentially, and define what we mean by autonomous systems in this case. Because you can start having this organization developing one standard and the other one developing a second standard, and then you end up with 4 different standards for the same topic, and you realize how insufficient this is, inefficient essentially, and you might even end up coming up with, let's find a standard that addresses all standards, and then you end up having 5 standards now again. So it's a never-ending loop.
That's exactly the war that I'm fearing, ISO versus ANSI. I know that the people that I've been talking to in the US are very committed to their course, and I know that there are those here in the UK are committed to a different course. And again, this is where I'm a bit fearful that the standard war could be our VHS versus Betamax. So Neil Cluffley has put up a question as more of a comment on issues of autonomy going wrong and going right, and I'll leave that to the panelists to either respond directly or the rest of the audience, but he definitely makes some interesting points. And then David McRoberts is talking about autonomy and the issues of single pilot versus 2 pilots. So we have set-tops, and then of course Garmin have introduced their Autoland technology, but not yet certified. So I think that's probably really just pointing that there's a long way to go, but the opportunity that autonomy is creating could be quite significant, save lives, help underpin the model. Chris, I'm going to start to wind things up, so I'm going to ask you to lead us off with some of your final thoughts, and then we'll move to Gary and then Alex to finish off.
Great. Yeah, I mean, for me, again, we've talked about it, but it's collaboration is absolutely critical here. And I think one of the things that actually sets aviation and aerospace apart from some of the other industries playing in the autonomy space is that safety culture and that spirit of collaboration to make things better. I think when you look back at how automotive tackled the autonomous vehicle problem, it was all very blinkers on, everybody take their own path, thinking that they could solve this problem on their own. And it's only actually in the last 2 or 3 years that the discourse has changed a little bit, and there's been an acknowledgement that it's too big for that approach. And things are starting to change in that world, and you have some of the disruptors moving from being technology companies to trying to build that safety culture in. So actually, we've got a real advantage there in the aviation industry. I think it's important that we support the primary research that's going on in the universities and the academic and industrial collaboration, because that's going to bring the building blocks that are needed to solve the assurance problems and build the certification strategies. Again, we need to avoid that standards war. The best standard I'm aware of, specifically focused on autonomous systems at the minute, has kind of come out of automotive, but has been developed in a more generic way, and it's through the Underwriters Laboratory in the US. But the UK's Safety Critical Systems Club has fed into that. So I think it's UL 4600. So it's, if anybody's interested, it's worth getting a copy of that. It's freely available. And again, leveraging the work of other sectors, we've got the University of York running an Assured Autonomy International programme that's funded by the Lloyd Registers Foundation. I think we've got to bring it all together, solve it as a community, and then we'll really unleash the potential. And then we can, we can realise the benefit that we've all talked about here today. We're working towards a sustainable future. We're working towards making things better. So let's work together to put the building blocks in place.
Brilliant, thank you. Gary, your last thoughts, please.
Well, I think that was a super summary from Chris, and I don't take people's time at this time of the day to kind of reiterate everything I said earlier. The couple of things I just want to point out to build on what Chris said is, as we look to these new aviation systems, we've always said there are a range of new technologies and innovations coming in every aspect of them, not just the vehicle, but the infrastructure systems, the use cases, and so on. So this, someone described it before, terrifying system of systems, real aggregate aviation system of systems. I will keep pulling us back to that. And the autonomy, as complex as the autonomous systems are, we have to think about how do they fit into that wider system. Therefore, when is the right place to use them? What's the right use case, and so on. So that's right back to Chris's. We've all got to keep talking to each other, and maximum collaboration is what's important. And the final thought, and here I am absolutely endorsing what Chris said, is aviation has an unenviable reputation for safety that's really hard fought. There is no way that what we'll do is take kind of risks to investigate how this might play out. We have to do this in a way that maintains that safety record, and I think we have a good position to do that from this industry. We can't let it go. So thank you.
Brilliant. Alex.
I'd like to also step on the point of the safety of the industry as well, and the levels of safety we take pride in having in our industry. It's a well-known fact that traveling by an aircraft is the safest form of transport, and it's getting safer by the year, essentially. To get to this point, obviously, there were accidents that happened in the past and so on, but the outcome of those events is that the aviation industry got safer and safer because we understood what could cause things to go wrong in the end, and allowed us to improve next day moving forward from there on. And it's one of the aims of the Innovation Hub as well, is to let these technologies be trialed and tested in a safe environment, where we want to encourage these technologies to go wrong in a safe way, so we can better understand what are the risks involved in these new technologies, how can we get in front of them and address them before they're integrated into the national airspace in this case, and all these new technologies we're seeing as well. So it goes back to our whole strategy and our whole approach we take to these innovative technologies, is to be as proactive as possible.
Brilliant. Thank you very much for that. Right. So on that, well, actually, I was just going to say, Alex, 10-15 minutes ago, I got the email from the CAA about the sandbox. So yes. I think the timing has been absolutely brilliant. So, gentlemen, thank you so much for your input. It's been absolutely fascinating. We're 39 minutes overdue, and I think Eric is about to throttle me. But thank you very much for that. I hope that it's been a good day for everybody. I know it's been a definite learning exercise for me. So I was Daryl Swanson, your moderator for today. And I think in the coming weeks or so, you'll be hearing from Eric on a potential virtual networking event, which we'd love to organize and give a bit more of an opportunity for everybody to talk about their favorite issues going forward. If you want, by all means, look me up on LinkedIn. I'd be happy to connect with anybody and further discussion. And I'm also on Twitter at Daryl Aviation. So I think with that, unless Eric, you have anything that you wanted to add into this? Right, Eric is being very quiet. He's either fumbling for the unmute or he's going to let me close it up. So with that, I'm going to draw this to a close, and I would like to thank all the speakers and panelists for their input and for the sponsors of the event. So thank you very much, and we'll see you soon.